This is section 2.5, is scatter plots and lines of best fit. On the very top of your notes handout, you see 3 graphs. The first graph has a line drawn in. What type of slope would you say that that line has? Positive. We would say that it has positive slope. What about this second graph? What type of slope would you say that that line has?
Negative.
It has negative slope. What about the third graph? Do we have a line?
No scale.
Could we draw a line through these points? No. I mean, we could, but I mean, what would we do? Just like connect the dots? I'm saying that's not quite what we're thinking. Is there really a trend there?
No.
There's not. Okay. So what we're trying to get at is on each of these graphs we have what we call a correlation. Sometimes there's positive correlation, sometimes there's negative correlation, and then sometimes there's no correlation at all. And the correlation is a result of your slope. So if we were to draw a line in that shows the general trend of this data, and this first one, I would say that this graph has a positive correlation. So on that line, write positive correlation. Positive correlation. Again, the word positive comes from the slope. The slope of that line is positive. For the second graph, obviously it has negative slope, so what would we say the correlation is? Negative correlation. And this third graph, it's not positive, it's not negative, so we would state that it has no correlation. When we create our scatter plot state, we're going to have to make this known whether we have positive, negative, or no correlation for each scatter plot. So if you look at the first scatter plot example that you have, it says the table shows data students collected on their test scores and the number of hours they watched the previous day. I went ahead and not given you the table, but instead of giving you the graph, I created the scatter plot for you. It says, what does the ordered pair 280 represent? What does it represent in the context of this problem?
She spent 2 hours watching television and only got 80% on her time.
That's correct. So we need to describe it. We would say the student spent 2 hours watching TV and scored an 80%. Part B says to draw a line of best fit. That's where this ruler is going to come into play. So when we draw these lines of best fit, it's not just a random line we're going to draw in. We want to draw a line that goes, not necessarily goes to as many points as we can, but shows the general trend of our data. It doesn't have to start at 0, 0. It doesn't have to start up here. It may sometimes. Is your line going to be exactly like my line? No, it's not. I drew my line. I tried to get it to go through as many points as I could. again, your line is probably slightly different than my line. When you draw that line of best fit in, I want you to make sure you are using. I want you to make sure you're using a straight edge. Don't freehand it. So here B, go to C. We've drawn our line in. What type of correlation would you guess this line to have? Negative. Negative. So we're going to state for part C, negative correlation. Alright, so this next part is where our answers are going to start varying, because you may not have exactly what I have. Part C says to write an equation for the line of best fit. Well, in order to write an equation, we have to have 2 points, or 2 ordered pairs. If you don't listen to anything else I say today, please listen to what I'm going to say next. When you're picking your ordered pairs, they do not have to be data points. They don't have to be one of these dots that are on your graph. They just have to be 2 points that are on the line. Okay? So in other words, I don't want to just pick these 2 points right here. I want to pick points that are on my red line. So when I'm selecting points this time, I'm actually considering this value right there, that ordered pair, which would be approximately 4.5, 60. So that's one of the ordered pairs I'm going to use. And again, 4.5, 60 may not be on your line, correct? If you didn't draw your line exactly like mine, it's probably not on your line. I need to pick another ordered pair, and again, it doesn't have to be a data point, but it could be. I'm going to use this point right here, which happens to be a data point, and that ordered pair is 280. So I have a second point, 280. If we have 2 ordered pairs, can we write an equation? Yeah, that's what we've been practicing, writing these equations, given some information. So let's go ahead and do that. Let's take our ordered pairs and find our slope first. So 80 minus 60 divided by 2 minus 4.5. So 80 minus 60 is 20. And 2 minus 4.5 is negative 2.5.
So everybody won't have the same answer?
No, you will not have exactly the same answer. It should be pretty close, but it won't be exact. Not likely, unless you pick the same order of pairs. If I divide, I'm going to get negative 8. So I want you to take note of something. The slope that we got is negative. Does our graph have a negative slope? It does. Make sure those jive. Slow yourself up, please. If your graph has positive slope and you have a negative slope, something's not quite right. Let's go to letter D. It says what? Wait, sorry, we're not quite ready for D. We gotta finish our equation here, don't we? Pick one of your ordered pairs to find B. I'm gonna pick the second ordered pair. AB equals negative 8. That's 2 plus B. Negative 8 times 2 is negative 16. Add 16. So my y-intercept is 96. Look at your graph. Could I have a y-intercept at about 96, do you think, where my graph crosses the y-axis? Change it with us? Could our graph have a y-intercept of 96?
Yes.
Yeah, our graph could. Our graph could cross the y-axis at 96. I think that's a good estimate for y-intercept. So, I've got my slope and y-intercept. Let's write an equation. Y equals negative 8x plus 96. The whole point of coming up with these equations is to use them to make a prediction about a future value. Make a prediction about a future value. Part D says, what test score would a student who spent 6 hours studying, what test score would a student who spent 6 hours watching TV get? So 6 hours, is that talking about an x or a y value? Look at your graph. Is the number of hours x or y? X. And if you look at your graph, here on the x-axis, they've got hours spent. So let's put in letter D, let's let X be 6 and figure out the score that the student might receive. Negative 8 times 6 is negative 48 plus 96. So if they scored a 48% on their test, should they have spent more or less time watching TV? Less time. Okay. Letter E. If a student scored 75% on their test, how many hours did they watch TV? So this time they're giving you 75%. Is that X or Y? That's Y. Your Y value. So this time let's let Y be 75. So let's put it into our equation and solve. Solving this equation, so I'm going to subtract 96. 75 minus 96 is negative 21. Divide by negative 8. We got X to be 2.625. Did you get that?
Yep.
Yeah. So 2.625 what? What is X representing on our graph?
Hours.
It's your X-axis. It's your hours. Now, if you had rounded that to 3 hours, I would take that. 2.6 hours, I would take that.
You don't want a fraction, do you?
No, let's leave it in terms of a decimal.
So, I did my points and I got 2.5.
That's fine. And your answer is close to mine? I think that's fine. I want you to look at something on your graph. Part E said if a student scored 75% on their test, how many hours do they watch TV? So 75%, so 60, 70, 75% is like right here. If I go over to where it meets my graph, and then I come back down, it's over in a straight line there. %, was here. And we're going to see when I meet my graph, we said about right there, what X value is that? It's about 2.5. Is that what we got?
Yeah.
I mean, or something close to it. When we did the algebra, we actually got 2.625, which is pretty close. So I think that our answer definitely jives with what the graph says. Check yourself, guys. Check yourself. I want you to show your work, but use your graph as a checking point. Don't just use your graph to give me the answer. Okay? Okay, number 5. Alright, number 5, it says the table below shows the grams of fat and the number of calories that are in certain foods. A, draw a scatter plot and a lineup best fit. Now in this case, I'm asking you guys to create this scatter plot. So it's important that you do this because you're going to need this for your homework. Right? You're going to need this particular scatter plot for your homework. So let's do this together. So on our x-axis, let's let that be the grams of fat. X-axis, we're going to let that be the grams of fat. The y-axis is going to be the number of calories. So let's talk about what we need to go by. On our x-axis, our numbers are 8, 4, 1, 10, 6, 19, 1, 9. What should we go by? We have to get all the way from 1 to 19. I believe there's 20. So we have enough to go by ones. Is that okay to go by ones?
Yeah.
Yes, and you guys realize that when you do this, you don't have to label every single box. I could label every fifth box. I'm still going by ones, but I'm only labeling every fifth box. That gets rid of that congested mess. Sometimes we get when we have a lot of information in a small area. Again, you guys are going to need this scatter plot for your homework, so make sure that you're following along with me and you're doing this. On the y-axis, our number of calories range looks like from 45 all the way to 245. So maybe go by 20s. We're going to have enough room. That will give us Yep, that'd be fun. Let's go by 20s. And I think I'm not going to label every one again. I'm going to go 20, 40, 60, 80, 100. You can label however many you want. I'm going to go each block is worth 20, but I'm only going to label every 100. So let's take our data from the table and let's plot our points. So our first ordered pair is 8, 150. 8, 150. 8, 20, 40, 50. We have 4 90s. We have 170. We have 10 185. We have 680. We have 19 2.45. Your graph looks similar to mine. Everybody have their graph plotted? Any questions? So we drew our scatter plot. It also asked us to do our line of best fit. Here's where I want you guys to step in. You guys should be able to finish this example. Draw in your line of best fit, and we'll do that part together.
So on the line, do you want it to go in between them?
I tried it. It's not necessarily going to touch all the points. I just try to get it to have an equal number of points above your line as below your line. So here I've got looks like 3 above, and then I've got 3 below. So that's a pretty good estimate as to where your graph should be. Everybody see that? I drew my line in. I had 3 points above my line, then I had 3 points below my line. That's a pretty good maybe average of semester. Yeah, that's fine. So then in the next part, it asks you to describe your correlation. How could you describe the correlation? In part C, I'm asking you to write a prediction equation. So you need to pick a couple of points. Can you do that? Now, or do they have to be data points? No, and if they could be, but you want to make sure you're picking points that are on your line. So pick points that are on your line. My points may not be the same points that you pick, correct?
Right.
Because your scatter plot may look a little bit different than mine. Okay? Right now, your goal is to finish these note pages. Okay? Finish this note page. So what is that? So it's 8. And what is that? It's 8. No. It's 8. There's your order 8. And you're up to what is that y value? So 8, 120. You could use that one because it's on your line. Doesn't actually happen to be a
I counted 45.
that's good because you're so busy. On the slope for these, it'll probably make your life easier if you would make them a decimal. So let's put the points on your line. 2 order pairs around this line. Those points on your line.
But it goes
So like the point C, put a dot right there.
so we have to have from 1 to at least 19. So we have 20 lines. So that's why we have
Right here, 5.
line equal 1.
What's another order pair that you go like this?
Because this is
That's not
going
as
to
good.
be that, so this is in the locality.
No, we don't have white, we don't have that. So it's just a continuation.
Yeah, it's just the way it's come.
So you've got 2 order pairs right.
So they're two separate.
No, it's all. Yeah, divide it. You want to subtract because it's plus. Yes, and on your slope. 2 order pairs.